Good day, ladies and gentlemen. This is Sarel van Grenen, aka Mr. VG, and I am excited to do the second series on grade 11, paper 1. The first series or set of videos was all about equations, and it also had some exponents in it, but this one video specifically is going to be about exponents, more the simplification, a little bit of solving of x with exponents, but I'm going to show you some of my tricks when it comes to this. So in this video, we are specifically going to look at this question 2.1 and 2.2. So I'm going to ask you to go for it, try it yourself, and then only you come back and you watch the rest of this video. When we look at question 2.1, I've highlighted the very, very important word for me, which is without the use of a calculator. Okay? So without the use of a calculator, it basically tells me that I am going to have to look at making my basis prime. So I'm going to take that expression, I'm going to change the 16 into 2 to the 4, same with the 81, 3 to the 4. And then I'm going to, you guys will see, as I do this video, that I don't worry about the power of negative a half initially. I will have a look at doing it right almost at the end. So I'm going to first simplify in the brackets and then do the power of negative a half later on. So let's take that x to the power of 2 over x to the power of negative 2. What does the second law say? The second law says I take the top exponent and I subtract the bottom exponent. So x to the power of 2 minus negative 2. This means that negative a half I haven't touched. Inside the bracket, I then am sitting with 2 to the 4, x to the 4 over 3 to the power of 4, still all to the power of negative a half. Now, at this moment of time, if you want to do this, you can just distribute that exponent in. But I don't want to do that. What I actually want to do is I want to look, if I look at that negative exponent, if there's one expression, meaning one term, inside the brackets, that negative can reciprocate your expression in the brackets. So in other words, I make the negative exponent, I make it a positive, and then my numerator and my denominator flips around. We call that reciprocating, okay, reciprocating. Then I'm now going to look at distributing the power of a half in. So I've got 3 to the power of 2, 2 to the power of 2, x to the power of 2, because I'm multiplying them, the exponents, with the power of a half. So in other words, I'm sitting with 9 over 4 x squared. When we look at the next sum, ladies and gentlemen, I see a plus in between terms at the top. Now that is going to make my spidey sense flare up and tell me I'm thinking about factorization. I'm thinking about factorization. So when we have a look at the sum, and I love these kind of sums, they will be asked in the exam. I'm first of all have to go to make the basis prime numbers. So when I make the basis prime numbers, 9 is 3 to the 2, 18 is 2 times 3 to the 2, and I put it in brackets. I love to put it in brackets because then I know I'm not going to forget something. I'm not going to forget one of the exponents. When I look at this specifically now, I'm going to split up that 3 to the 2x plus 1. I'm looking at that in the same breath of air that I'm going to look at distributing the x into the 2, that x in there, as well as that x in there. So I'm going to do two things at once. I'm going to remove the brackets and I'm splitting up that exponent. Same at the bottom, I'm going to distribute that x in the denominator. At the top, where there is a plus, guess what I'm going to do? I'm going to take out something common. So I'm left with 1 plus 1 times 3. Again, as in the previous video, wherever I take something out, I put a 1 there. So I know that I won't forget any of the terms. In the denominator, I'm just going to shuffle, and I'm applying the first exponential law by multiplying the 2's and therefore adding the exponents. The 3 to the power of 2x's divide away, and I'm left with 1 plus 3 over 2 to the power of 0. Where does the 3 come from again? I'm multiplying. I'm saying 1 times 3 is 3, which means in the numerator, I've got 4. In the denominator, 2 to the power of 0 is 1. Hence, my answer is 4. Looking at the next sum, ladies and gentlemen, this is a bit of an interesting sum because it's kind of a mixture of exponents and surd equations. So the first thing we need to start looking at is, remember, I want to try and get rid of the surd. So to get rid of the surd, I must first see, is the surd alone on one side? Yes, it is. That surd is alone. Therefore, I can square both sides. To make life a little bit simpler, I'm going to write out my right-hand side, the 3 to the x minus 2, into two brackets. Remember, it is multiplying 3 to the power of x minus 2 with itself. If I distribute that out, I get 3 to the power of 2x minus 2 times by 3 to the x minus another 2 times 3 to the x plus 4. This means on the right-hand side, I can simplify it. But also, I'm going to take a wild guess and make it equal to 0. Okay? This is kind of my spidey sense tingling. Why do my spidey sense tingle again? Because I'm seeing there's a 2x and there's an x. Whenever I see this, I'm thinking about quadratics. Because 3 to the x squared is going to give me 3 to the 2x. Okay? It's just one of those things that I love to look for when I'm working with exponents, is when one exponent is double the other one. And we'll see later on why. This means my simplified expression on the right-hand side is now 2 times by 3 to the 2x minus 4 times 3 to the x minus 6. And my exponent is twice. The 2x is twice x. So let's first divide by 2 to make our factorization easier. What I do on the right-hand side, I've got to do on the left as well. So therefore, I'm sitting with 3 to the 2x minus 2 times by 3 to the x minus 3. And this now becomes, for me, a k substitution sum. And how do I know it? Because the one exponent is twice the other one. So I'm going to let my 3 to the x be equal to k. Why is that? Because 3 to the 2x is k squared, and 3 to the x is just k. If you're getting a little bit confused, remember 3 to the 2x means 3 to the x squared. So on the right-hand side, I'm going to factorize that. Oh, there you go. I'm writing it out twice for you, okay? So let me just erase that bottom one. There we go, okay? 3 to the 2x is 3 to the x squared. So when I now look at factorizing the right-hand side, I've got k minus 3 and k plus 1. Solving for k gives me k equal to 3 or k equal to negative 1. But did I ask you to solve k or did I ask you to solve x? I asked you to solve x. So I'm going to substitute the 3 to the x back in, and I'm sitting with 3 to the x equal to 3 or 3 to the x equal to negative 1. If I look at the first one, 3 to the x equal to 3, x must be 1. But why did I put a red line through that equal on the right? Think about it. 3 to the power of anything, can it be negative 1? Well, the answer is no. Because 3 to the power of, for instance, 1 gives me positive 3. While if I go and say 3 to the negative 1, well, that's 1 over 3 to the positive 1. So no matter what values I substitute for x into that left-hand side, into 3 to the x, my answer is never going to be smaller than 0. When you think about a graph of 3 to the x, and I'm looking at the value of negative 1, there is no place where my graph is going to equal negative 1. This is just a visual way of thinking about it, okay? I love to think about things visually. But because we worked back to the sum, because we worked with a square root, I am still going to check my answers. So checking my answer, okay, substituting x with 1, my left-hand side is equal to my right-hand side, okay? Humblest apologies for writing over each other. I'm just substituting that x equal to 1 in the left and on the right, and it does work out, so I know that x is negative 1. Bit of a difficult sum, but that's why it's 5 marks. Let's have a look at the last question for today. This one is a pure insight question. Ladies and gents, it's a 4-mark question, it's I think 4 marks, but it's a level 4 question, pure and simple. If I look at this left-hand side and I look at right-hand side, the problem we have, and I'm saying this to you, is you cannot, for instance, square both sides because we don't have them equal to one another. I have to try and change the left-hand side into the right-hand side or vice versa. Now, I tried this in a number of ways until I found a secret. If I look at this, going from left to right, one of the main things that I need to do is I need to get a square root over the whole left-hand side. So if I want to get a square root over the whole left-hand side, I've also got to square it in the same breath of air. Why? Because the square and the square root cancel each other out. I'm using inverted commas. They are inverse operations of one another. So if I want to square root the left, I also have to square it so that I don't really change it. I manipulate it. I don't change the value, although I manipulate the left-hand side. So what I'm going to try and do now is I'm going to square out inside the root. So I'm going to see if I square that 3 root 2a minus 2 root 3a, I square it out, what do I get? So inside the root, I'm going to sit with a big expression. But that big expression comes from taking that bracket under the root, squaring it out. So I'm going to one by one multiply that one with that one, the firsts, the outers, the inners, and the lasts. It's amazing how actually grade 9 mathematics come into play. So in other words, 3 times 3 is 9, and root 2a times by root 2a is root 2a squared. Then if I multiply out my outers, 6 times 2 is, 3 times 2 is 6. And then I'm sitting with root 3a times by root 2a. But if you look at the inners, it's going to be exactly the same. So I'm going to multiply it by 2. If I multiply out the outers, or the lasts I mean, negative 2 times by negative 2 is positive 4. And root 3a times by root 3a, well, that is root 3a squared. Now let's see if we can't simplify that expression. That means I've got 9 times by 2a. I've got 6 times 2, which gives me 12. And because the root 3a and the root 2a are having the same surds, they're both square roots, I'm going to make them into one square root. And therefore my last little term is just going to be 4 times by 3a. Now 9 times 2a is 18a, and 4 times 3a is 12a. So what is 18a plus 12a? Oh my goodness, that's root 30, that's 30a. Yes! So that is my first term under my square root. If I now look, oh my goodness, I've got a 12 as well. So that is fantastic. So I'm going to write it there. But now, what is the root of 3a times 2a? Let's first multiply that out. Well, that's 6a. The root of, whoa. Why is that just an a? Okay, let me take it step by step. Inside the root, I have 3 times 2, which is 6. A times a, which is a squared. Now, what is the root of a squared? Well, that's just a. But please don't forget that that root goes over both there. So I'm basically saying the root of 6a squared is the root of 6 times by the root of a squared. And that is the root of 6a, which I wrote there. Oh my hat. That's exactly what I was looking for. Woo! This was a beautiful question, ladies and gentlemen. Absolutely gorgeous. So I would encourage you to go and try this one yourself again. And this is definitely the kind of sum that an examiner puts in because they know maybe 1 or 2% of the population would be able to get this right. So if you are a 70 or 60%, ladies and gents, this is the kind of sum where you look at what I did, why I do it, and try it. But don't spend hours and hours and hours on trying to see this. If you look at this and you go, sir, what the hell did you do? I would never think about something like this. That's okay. That's 100% okay. But if you are aiming for 100%, realistically speaking, these are the kind of sums that you must start thinking about. What do I do? And it's all about looking at where you are without a square root over everything and then looking where you're going. I need a square root over everything. So I manipulate the living daylights out of that sum. Ladies and gents, this is Mr. VG signing out. Have a beautiful, amazing rest of your day. Keep well. Cheers.